In this video, we're going to be discussing indices, the laws of indices, and then solving questions on indices. So let's start. Then the laws of indices, number one, states that x to the power a multiplied by x to the power b is equals to x to the power a plus b. Then, for example, 2 to the power 2 multiplied by 2 to the power 3 is equals to 2 to the power 2 plus 3, which is equals to 2 to the power 5, which is 32. So remember, this is the bases are equal. They have the same basis. So, but remember, they have the same basis. So the second law of indices states that x to the power a divided by x to the power b is equal to x to the power a minus b. And this x to the power a divided by x to the power b can also be written as x to the power a over x to the power b, which is same as x to the power a minus b. And then example of this law, let's say 2 to the power 3 divided by 2 to the power 2. So this is equal to 2 to the power 3 minus 2, which is equals to 2 to the power 5. 2 to the power 1, which is same as equals to 2. And it makes sense. 2 to the power 3 is equals to 8 divided by 2 to the power 2, which is equals to 4. So 8 divided by 4 is equals to 2. So that's it about the second law of indices. Then the third law of indices states that x to the power 0 is equals to 1. So I'm going to prove this. So I'm going to prove this at the end of this video. So the fourth law states that x to the power negative a is equals to 1 over x to the power a. Example of this is this. Let's say we have 3 to the power negative 2. This is equal to 1 over 3 to the power 2, which is equals to 1 over 3 to the power 2 is equal to 9. So the fifth law of indices states that x to the power a, all in bracket, multiplied by b is equal to x to the power a times b. Now, example of this is this. Let's say we have 2 to the power 2 in brackets, all raised to the power, that's 3. So this is equal to 2 to the power 2 times 3, which is equals to 2 to the power 6. So the fifth law, or the sixth law, sorry, states that x to the power 1 over a is same thing as the 8th root of x to the power 1. So example of this is, let's say you have 3 raised to the power 1 over 2. Then this is equal to square root of 3 raised to the power this one. Then the seventh law is related to the sixth law, which states that x to the power b over a is same thing as 8th root of x all raised to the power b. Now the a takes the root and then the power takes the b. So this is same thing as let's say we have 4 to the power 3 over 2. So this is the same thing as square root of 4. These two, because of these two here, square root of 4. Then all raised to the power 3. This is equals to square root of 4 is 2. 2 raised to the power 3, which is equals to 8. So indices is all about simplifying numbers to its lowest term. So let's say we have 10. So this 10 can be simplified further as 2 times 5. Or let's say we have something like 9. It can be simplified further as 3 times 3 or 3 square. Also 4 can be simplified further as 2 square or 2 times 2. So it depends on what you are solving and what they want you to do. So let's solve practice questions. So let's solve this question 1. Let's say we are given this to solve in indices. So how are we going to solve it? Let's start. So 8 raised to the power 1 over 3 can be written as, now 8 can be written as 2 raised to the power 3. Now all raised to the power 1 over 3 multiplied by 5 to the power 2 over 3. Then all over. Then this 10 can be written as 2 times 5 all to the power 2 over 3. Now, and this is equals to, now remember from this law, which law? From the fifth law, fifth law, which says that x to the power a multiplied by or multiplied by to the power b is equal to x to the power a times b. We are going to apply it here. 2 to the power 3 multiplied by a power of 1 over 3. We are going to be writing it as 2 to the power 3 multiplied by 1 over 3, the same thing as 3 over 3. Then times 5 to the power 2 over 3 all over. We are going to distribute this 2 over 3 to 2 and 5. So we have 2 to the power 2 over 3 multiplied by 5 to the power 2 over 3. And so we have 2 to the power 3 over 3 is same thing as 2 multiplied by 5 to the power 2 over 3 over 2 to the power 2 over 3 multiplied by 5 to the power 2 over 3. So there's the way I'm going to write this in so that it can be easily understood. So you have 2 times 1 over 2 to the power 2 over 3 multiplied by 5 raised to the power 2 over 3 times 1 over 5 multiplied by 2 over 3. So this thing I wrote here is the same as this, because when to multiply this, it will be 2 over 2 to the power 2 over 3, and when 5 to the power 2 over 3 multiply 1, it will be 5 power 2 over 3 over 5 to the power 2 over 3. So we have 2 times 1 over 2 over 3 can be written as 2 times 1 over 2 to the power 2 over 3 can be written as 2 to the power minus 2 over 3. That's from the fourth law. Remember, 1 over x to the power a is the same thing as, can be written as x to the power 1 over a. That's just what we did here. 1 over 2 to the power 2 over 3 is 2 to the power 1 minus 2 over 3. So this multiplied by 5 to the power 2 over 3. And then the same thing we did here, let's do it here too. So this multiplied by 5 negative 2 over 3. So we have 2 multiplied by, then 2 raised to the power 1 multiplied by 2 to the power negative 2 over 3 times, now 2 over 3 minus, remember this from here now, we're going to apply the first law, which states as x to the power a multiplied by x to the power b is equal to x to the power a plus b. So we are going to, since they are the same basis, we're going to add their power. So 2 over 3 minus 2 over 3 is 0. So this gives us 5 to the power 0. So we have that. And then we are going to add 1 minus 2 over 3 because the bases are the same, gotten from the first law. So 2 1 minus 2 over 3 times 5 to the power 0 is 1 from law 3. So 1 minus 2 over 3 the same thing as 2 to the power 3 over 2 divided by 3, then times 1, which is equal to 2 to the power 1 over 3. Or from the sixth law, we have that 2 to the power 1 over 3 is also equals to cube root of 2. This is our final answer. So let's have the second question. We have cube root of, in bracket, 64 r to the power negative 6. then close bracket, raised to power half. So this is equal to 64 r to the power negative 6 raised to power half, then to power 1 over 3. Remember, from the sixth law, we have that x to the power 1 over a is same thing as a to root of x. So that's what we did here. This is cube root of 3. So we just root it as 64 r to the power negative 6 to the power half, then 1 over 3. Now this 1 over 3 can be gotten from this now. So, and this is equal to 64 r to the power negative 6. We are going to multiply this negative 1 over 3, sorry, with 1 over 2. That's from the fifth law. So 1 over 2 times 1 over 3 is going to give us 1 over 6. And then this is equal to, this is r raised to the power negative 6. Then it then shows that something raised to the power 6 will give us 64. This is 6, this is 6. It shows that something to the power 6 will give us 64. I know that thing is 2. So we have that 2 to the power 6 multiplied by r to the power negative 6, then all raised to the power 1 over 6. So let's use this 6 to multiply all the powers. I mean this 1 over 6 to multiply all the powers. So we have 2 to the power 6 times 1 over 6 multiplied by r to the power negative 6 multiplied by 1 over 6. So this is equal to 2 to the power 6 over 6 multiplied by r to the power negative 6 over 6, which is equal to 2 to the power 1 multiplied by r to the power negative 1. So we have 2 r to the power negative 1. So remember that these 2 r to the power negative 1 can be written as 2 times r to the power negative 1, now which is also equal to 2 times 1 over r. Remember, r to the power negative 1 can be written as 1 over r. That is from law 4. That's from this fourth law. From the fourth law, x to the power negative a is the same thing as 1 over x to the power a. So r to the power negative 1 is the same thing as 1 over r. So our final answer is equals to 2 over r. So let's solve this third question. We have 27 over 5 multiplied by 3 to the power negative 3 multiplied by 1 over 5 to the power negative 1. So let's start. So we have 27 over 5 multiplied by, remember 3 to the power negative 3 can be written as 1 over 3 to the power 3. Then multiplied by, and then this 1 over 5 to negative 1 is simply equals to 5. Now see the reason. Remember, x raised to the power negative 1 is equals to 1 over x, right? So 1 over 5 to the power negative 1 is simply equals to 1 over 5. So let's multiply the numerator and denominator by 5 to clear this fraction. So 5 multiplied by 5 is 1, and then 5 multiplied by 1 simply equals to 5. So that's the reason. And this is equals to 27 over 5 multiplied by 1 over, remember 3 raised to the power 3 is equals to 27, then multiply by 5, and then let's cancel this 5, cancel, and then cancel. We have 1 as the answer, so this is the correct answer. So let's solve this last question. So we have square root of 160 r square plus square root of 71 r raised to the power 4 plus square root of 100 r to the power 8. Now this square root is covering this one, and then this one is covering this one, this one is covering this 100 to 100 r to the power 8. So let's start. This is equals to square root of 160 r square plus root 71 r 4 plus. Now let's solve this root 100 r to the power 8. So we have root 100 r to the power 8. Now from indices, 100 r to the power 8 can be written as, then in square root can be written as 100 r to the power 8 raised to the power half, or this half from the square root. And so from indices 2, we can multiply half with 8. So we have 100 r to the power 8 multiplied by half, which will give us 100 r to the power 4, because 2 multiplies everyone, 2 multiplied by 2 divided by 8 is 4. So we have 100 r to the power 4. And we're also going to multiply, this is power of 1. We're going to multiply 1 with 1 over half. So we have 100 to the power half. So, and then this means square root of 100 multiplied by r to the power 4. And square root of 100 is 10. Right? Yeah, 10 multiplied by r to the power 4. So we have 10 r to the power 4. So we're going to replace this root 100 r to the power 8 with 10 r to the power 4. So we have plus 10 r to the power 4. Notice that we have r to the power 4 and we have r to the power 4. So we're going to add 71 plus 10 r to the power 4. So we have root 160 r square plus square root of 71 plus 10 is 81 r to the power 4. So we're going to do the same thing we did here to this root 81 r to the power 4. So we have root 81 r to the power 4 is the same thing as 81 r to the power 4 raised to the power half. So we're going to distribute this half to this and this. So we have 81 to the power half multiplied by r to the power 4 multiplied by half. So 81 to the power half is the same thing as root 81, which is equals to 9. And then 2 divided 4 will give us 2. So we have 9 r to the power 2. So we're going to replace 81 r to the power 4, that is all in square root 2, with 9 r to the power 2. So we have this is equal to root 160 r to the power 2 plus 9 r to the power 2, and this is equal to root 169 r to the power 2. So let's do the same thing we did here. So we have, and this is equal to 169 r square raised to the power half. So let's multiply 2 with half and then 1 with half. We have 169 to the power half multiplied by r square times half. Then this is equal to square root of 169 multiplied by r, because 2 divided by 2 is 1. So, and root 169 is equals to 13. So I have 13 times r, which is equals to 13r. So this is the answer. To prove that x to the power 0 is equals to 1, remember that x over x is equal to 1. And then from second law of indices, we have that x to the power a divided by x to the power b is equals to x to the power a minus b. And hence we can write this as x to the power 1 minus 1, because the power of this x is 1, So we have x to the power 1 minus 1 is 0, x power 0, which is equals to 1. This. So that's just how to prove that x to the power 0 is equals to 1.